Flight controls. The primary flight controls on the Avro RJ are ailerons for roll control, elevators for pitch control, and a rudder for yaw control. Only the ailerons and elevators are controlled mechanically by servo tabs. The rudder is controlled hydraulically. Additional roll control is provided by hydraulically powered roll spoilers. All three primary flight controls can be independently trimmed to assist the flight crew in maintaining straight and level flight. A stall warning system is available to warn the pilot of an impending stall. Moreover, if the angle of attack is further increased to allow an actual stall condition to develop, a stall identification system pushes the control column forward. The secondary flight controls on the Avro RJ are the flaps, lift spoilers, and the air brake. Flaps and lift spoilers are operated by both hydraulic systems, whereas the air brake is operated by the green system only. Two ailerons, assisted by hydraulically powered roll spoilers, provide roll control. As the aileron itself is not hydraulically powered, a servo tab is fitted to each aileron to reduce the effort required by the pilot. The aileron servo tabs are controlled by two interconnected circuits. Each pilot normally has control of both circuits via one hand wheel. Again, input to a hand wheel directly moves the servo tab and not the aileron itself. The two circuits are interconnected via the two hand wheels through a collapsible strut under the flight deck floor. Additionally, both aileron surfaces are interconnected to ensure movement in opposite directions. Artificial feel in the aileron circuit is through a spring strut in the left-hand circuit, which increases the load on the hand wheel as the pilot input increases. Should one aileron circuit mechanically jam, both circuits can be disconnected to restore single-circuit roll control through a single hand wheel. The aileron circuits are disconnected by forceful rotation of the two hand wheels in opposite directions. That causes the collapsible strut to break into two parts, one sliding within the other. The breakout of the collapsible strut will electrically sense the aileron interconnection to open. This opened interconnection of both ailerons will allow them to move independently so that the jammed circuit will not restrict the other one in free movement. After the ailerons are disconnected, the amber central warning panel caption, "Aileron Elevator Uncoupled," comes on. A red T-handle on the center pedestal is fitted to send an electric disconnect signal, additionally to the collapsible strut to the aileron interconnection circuit. The T-handle forms a backup to the electric signal from the collapsible strut. A mechanical interlock on the T-handle prevents inadvertent operation. Once the aileron interconnect circuit has been split, it cannot be reset in flight. Maintenance personnel on ground are necessary. The two roll spoilers, hydraulically powered by the yellow system and mechanically controlled by the respective servo tab cable, assist the upgoing aileron by destroying lift on the downgoing wing. Maximum roll spoiler deployment angle is 10 degrees. Indication of roll spoiler deployment, maximum 10 degrees, is shown on two gauges above the central warning panel. To prevent unnecessary spoiler movement, they do not deploy for small control inputs. However, they are fully deployed before the hand wheel reaches full travel. Each aileron has a mechanically operated trim tab. Aileron trim is applied by a wheel on a center console. Trim position from neutral to full left or right is indicated in a small window above. The neutral aileron trim position is achieved when both the orange position marker in the window and the orange marking on the wheel are aligned. Aileron trim has to be in a neutral position for takeoff. Pitch control is provided by two elevators which are operated aerodynamically by servo tabs. Gust dampers at each aileron and elevator surface prevent damage to the flight controls when the aircraft is parked in strong winds. They work automatically by preventing fast and forceful movements, but do not restrict any input in flight. No control surface lock is fitted, but there is a control column restraint on the captain's side which prevents column movements on ground. The elevator servo tabs are controlled by two normally interconnected circuits. Each pilot has control of both circuits via the respective control column, as both control columns are interconnected by a strut below the flight deck, similar to the aileron system you already know. There is neither a connection between the control column and the elevator surface, nor between the elevator surfaces themselves. In the event of a mechanical jam in one of the elevator control circuits, they can be disconnected to allow reduced pitch control from the free circuit. Disconnection is achieved by forcing both columns in opposite directions, which causes their connecting mechanism to split. When the columns are realigned, they will, and that is an important difference to the aileron system, be reconnected by their strut. After a disconnect was achieved by forcing the columns in opposite directions, reconnection of the circuits can be prevented by pulling the T-handle on the center console, which opens a clutch. When the handle is fully pulled out, a mechanical interlock prevents inadvertent reset of the T-handle until the knob on the T-handle is pushed and the T-handle pushed in again. When this clutch is open, the amber aileron elevator uncoupled caption on the central warning panel is illuminated. The elevator control circuits can be reconnected in flight by realigning both control columns and pushing in the T-handle. Artificial feel in the elevator circuits is provided by a pneumatic Q-feel system in a left-hand circuit and a G-weight in a right-hand circuit. The G-weight uses a mechanical weight to increase the load on the control column as G-load changes. Here you can see the G-load increase case. The Q-feel system uses pitot air pressure to increase the load on the control column with increasing airspeed and vice versa. Should the Q-feel system fail, an amber central warning panel caption, "Rudder elevator Q-fail," will come on. Both feel systems are normally in operation as both control circuits are available and connected. Should one circuit jam with a subsequent disconnection of the two circuits, only the feel system in the free circuit remains available. In this example, the Q-feel system stays online. Each elevator surface is fitted with a trim tab. The trim tab can be operated either mechanically or electrically. Trim can be applied manually from one of the two interconnected trim wheels, either side of the center console. Trim position is indicated in a window below the thrust levers. Pitch trim must be in the green band for takeoff. Both trim tabs can also be driven electrically by a trim motor in the horizontal stabilizer. The left motor is always fitted, whereas the right motor is only fitted to aircraft with two flight guidance computers. Be aware that only one motor at a time moves both trim tabs. When FGC-1 is selected on the flight deck, the left motor is used and the right one when FGC-2 is in use. The trim motor can be controlled manually by thumb switches on each pilot's hand wheel or automatically from the selected flight guidance system. The trim switches, also called thumb switches, are comprised of two parts. Both of these switches must be operated in the same direction to achieve a trim change. If the thumb switches are operated when the autopilot is on, it will disconnect automatically. The flight guidance system can automatically trim the aircraft in pitch during flight. This is called auto trim. This is solely indicated by movement of the trim wheels and the trim position indicator window. Additionally to auto trim, the flight guidance system is capable of compensating large out-of-trim forces during flap movement in the following way. Automatic application of the nose-down trim when flaps are extended from 0 degrees to 18 degrees. The nose-up trim when flaps are retracted from 18 degrees to 0 degrees. Flap trim compensation